Let's start. Hi everyone, and welcome to our webinar on running Kubernetes on a manufacturing line. I'm Caroline. I'm here in the background today, so if you have any organizational questions, I'm here. And for the more important and interesting part, we have Tobi and Mario joining us. For those of you who were at KubeCon last week, I hope you were enjoying the conference as much as our team did. I unfortunately couldn't join, but when I see the pictures, it looks like that you were having a lot of fun and that crazy things were happening on site. Tobi and Mario, who will be presenting today, they were also on stage at KubeCon last Friday to talk about this topic. And it seems like that Kubernetes on edge for the manufacturing industry becomes more and more important. So let's talk about this use case today. Our team has been working on that for quite some time now. So there will be some exciting insights they can share today. Our presenters will be Mario and Tobi. They both have been involved in this project heavily, and I would say that they know all the details like no one else in the company. So they can give you all the interesting details, and they will show you the obvious and non-obvious challenges of cloud native adopters for the Industry 4.0 sector. But before we get started with the fun part, just some organizational stuff first. If you have any questions during the presentation, please use the Q&A chat window that you can see below so that we can either answer them straight away or in the Q&A session right after the talk. And yes, since this questions always arises, we are recording the session. So in case you need to drop out earlier, no worries, you will get the replay per email. You can find it on the website or on our social media channels. So there's a bunch of ways of rewatching this whenever it suits you. And with that, handing over to Mario and Tobi.
Yes, so welcome everyone. This is going to be interesting because we only gave this talk live on stage, which is some kind of new in the last 2 years, but Tobi and me practiced this only online. So hopefully everything will be fine. You should see my screen now, and we are here to talk about running Kubernetes in a manufacturing line. What could possibly go wrong, Tobi?
Correct. So if you try to start with Kubernetes on a chemical factory line, there are a few things that are different between normal Kubernetes projects, and that's what we want to talk about today. So to my person, sorry, I need to find the next button, but now the window was hidden. No. Okay, here we go. So what about my person? I'm working for Kubernetes mostly 4 years now. Started with containers and Kubernetes, OpenShift, this stuff already 7 years ago. So interesting task, and working as principal architect, and was like since the beginning of the project involved in this project at the chemical factory.
Yeah, and I'm Mario. I work for Kubernetes since roughly 1.5 years. I joined together with Tobi in this project endeavor, and we basically started as a 2-man team this whole project, and we are still doing the global architecture for this project and fixing incidents that happen if we are available. So to go back in time a little bit, we need to see how does our industry evolved in the past. So when we go back to the end of the 18th century, we had the first bigger factories that are produced weaveries and stuff like this. So where we got to the level that there's a first mass production with the help of water power and steam power and mechanization. The next step was in the beginning of the 20th century with the first assembly lines, the first electricity that's being used. We can see this in the first automotive mass production done by Ford. And we got then to the point where we started to use computers and automation, which is the start of the 1970s. And this evolved to the point where we are today. It's the cyber physical systems and virtual plant interaction, which is the present for most of our companies. And they use heavily IT involved structures directly on the manufacturing line. There are monitors, there are overwatch systems, and we even get to the point where we have a closer look on Industry 4.0, where we have AI supported systems that basically take screenshots of every second in your manufacturing line and adopting to changes rapidly so that you have an improved outcome, and also that you have real-time analysis, and also can stop the production if it's necessary, or have motion control. The problem that we have there is that it's usually not one manufacturing site, but there are multiple manufacturing sites. So they need to talk to each other, but they also need to be self-sufficient, because if they are not self-sufficient at this point, we lose a high amount of money. So it's in the high six figures that we lose by 1 hour of outage. And also what we need to keep in mind, we are always in danger of cyber attacks, and this became more and more real in the last couple of months. So we need interconnection between our manufacturing sites. We need information transparency so that everything is everywhere accessible. We need also decentralized decisions so that we still can run our factory by its own. And to cope with this whole data mass that we need a resilient system where we run our applications on. And the best thing to do this is Kubernetes, and this is how we planned to implement it in a chemical manufacturing line.
Yeah, so how we get started there. So basically we thought, Kubernetes, we know, but we don't know chemical industry. And that was in the beginning, like the main challenge first, to really find out what is the special thing about running Kubernetes in a manufacturing line in a chemical producing company. So because you can think about if something went wrong, we potentially have a lot of loss of money, or even bigger things like better production line get exploded or something like that. So for that, we had defined some key project targets. So for us, we found, okay, what is necessary to do is we need to host manufacturing software. So this is different as normal software. Why? We need to interact with, or the software needs to interact with a lot of sensors on the production line, with devices like tablets or printers to print their production orders. And this is somehow mostly not cloud native. Say moving to this target, but most of the stuff is more maybe traditional software as you can expect. And the target of our customer was to like building a cloud native middleware by themselves with microservices to connect like this old school application, new dynamic things like this picture recognition, control software, and ERP systems. And this brought us to the network side. So this is isolated network, is completely isolated from the IT. It's a dedicated zone, it's a dedicated firewall, and we talk about multiple firewalls here because we have 3 or 4 as far as we know. And this brought us to the key target that we want to have a high grade of automation, because finding it out once is hard enough, but the best thing how we can ensure you run it throughout the time, and we're talking about time windows on 3-5 years, is to automate it and make it repeatable. That in the disaster case, you can also repeat the software. Independence is something what is important because like we have multiple manufacturing plants and this must be independent, and also the operation for the Microsoft must be independent. More details later. Also the high availability. One other thing is end-to-end operation across all departments, but this will be covered by Mario later, how we manage that we can interact with multiple departments on the same target. Cool. So what independence means in our case here, we need a fast development. Why? Technology is like a key driver now for the businesses, not even in IT businesses, it's also for other businesses like here in the manufacturing line. They need to be fast, they need to be adapt to the market. The best thing was the production of the Corona vaccines so that they can adapt quickly to produce such things. Decouple dependencies means an update A should not block our update B. That means in detail, we as a platform provider for Kubernetes should not be a restrictive blocker for a microservice deployment or microservice deployments around or between different environments. So this must be super decoupled by an API, and we should be focused more like a self-service. As we know in the cloud, we want to be this also on the on-premise side. We want to be able that we say, okay, the team don't need to open tickets. When they need something, they need to consume it. And this is very important for making this cross-functional teams really workable, because they cannot just do meetings to coordinate. They need to concentrate on their complexity. And this complexity is hard. This complexity needs to be in mind, okay, we want to keep it in a 2-pizza team that we can handle these components individually and separated from each other, what mostly means also separate release cycle. Okay, so what means high availability? For us, high availability in Kubernetes perspective is we want to be HA from each cluster and distributed across locations and multiple failure zones. That means we have, in this case, at the customer, we have implemented right now 3 different data centers. 1 is in the cloud, 2 are on-prem. But in the future, we have the scale-up plan until to 30 data centers. And these data centers must be work independently from each other. This means one can be shut down and all others could be work further. And in the data center itself, we have also failure zones where one failure zone can fail and the others should survive without any outage. And therefore, we get a target SLA about 99.96% across all clusters and locations. This means if everything would be down, we have a monthly downtime of 70 minutes. That's really not much. So 70 minutes is really something, if you have a problem, what runs out of it. And in the year, 3 hours, you can expecting 3 hours in a year if you do Kubernetes could be maybe a challenge. And this is basically our journey. And now Mario can take over how we managed first the organizational part of it.
Yeah, as you can imagine, as you can imagine, it's always a problem when you work for enterprise companies. It's really, really big, and they have a lot of teams, and they have different departments, and they have also different requirements. So you need to work closely together with your counterparts. For this, our customer created a counterpart team, which are basically the in-house stakeholders. And together with them, we work closely in sprint base to really set up the whole infrastructure and provide the service, and also discuss the managed service aspect of it. But those in-house stakeholders, they also get requirements from different departments. So they have requirements that hey, I want to run my application on your Kubernetes clusters, or I want to run a database on your Kubernetes clusters. So they need to also to talk to their in-house data warehousing teams. They also need to talk and bring up their requirements to our stakeholder team. But they are also the problem that there's always this big part of a company which is called security, and with security, everyone needs to talk. This brings us to the point where we say we cannot do this by ourselves, and also our customer cannot do this by ourselves. So we created basically a board and a split of competence so that we have teams for very specific parts of the project that work together to achieve the final goal of running the platform and keeping the platform up and running and maintaining the platform. And we decided that we should go with four different teams, although one of the four teams is like a really big and not so defined team. So we started with one team that needs to take care of the core infrastructure. The core infrastructure team is basically the team that is working for providing the basic infrastructure that Kubernetes or the Kubernetes platform is running on. So we basically use Azure for our master setup in the cloud, and inside of the data centers next to each of the locations of the manufacturing line, we use vSphere, and in the future we are planning to use also bare metal clusters with KubeVirt. Also, this team needs to take care about the firewall settings and the cloud and on-prem connection, and also they are involved in the resource reservation and cost control. However, to manage those capacities, they also need information from us and from the system and from the other teams. So the next team that is really important is basically our direct counterpart that we are engaged to. That is the application platform team, and they provide basically Kubernetes as a service for their different app departments inside of the company. And also they provide like a base service infrastructure, like, oh, I need some Kafka topics, I need an S3 bucket, and also I need some certificates. So this team is the direct counterpart where customers come to and say, hey, I need a cluster, I need this namespace, and they provide everything of this, and they go with the DevOps paradigmas. And now we come to the biggest and most unknown team for us, because we don't have a direct interaction with them. I mean, the only thing that we get from them are sometimes requirements, but usually they are the drivers for the requirements for the platform, what they want to run on. So these are a lot of departments stretched all across the company, and they require different sizes of clusters and different settings of clusters. And they usually request this with the application platform team that we saw before. They are also moving into a fast and agile approach. So the lifespan of clusters is getting really short, and also they need to spin up fast, or they need to increase as fast as possible. And for this, to provide this basic structure, this is basically where our team comes in, and we are the cloud native infrastructure team. We basically provide the platform to host the Kubernetes clusters and to create those Kubernetes clusters, but we also provide a couple of basic services that we will see in a couple of minutes that is also needed to run your data center independently. But of course, as we are in an enterprise environment, we are also responsible for metering reports, consumption reports, and making scaling possible so that it's as cost efficient as possible. And for us, it was the logical step yeah, let's do this with Kubernetes. And then we started implementing our theoretical construct.
Yeah, and we said basically, yeah, challenge accepted. Why not? Why not doing this? So yeah, let's talk about what was then after we saw, okay, that's our part. That's how the organization is working. We have a plan. What can help us? So here we found like a pattern what we really tried to implement in everything, like repeatable function units. That means if a problem is too complex, you know it from the HR, we'll make it smaller. The same thing we tried to do for our project with our components. So, and then we said, okay, what help us to do this? So everything what we do should get managed by an API or a GitOps approach. So basically the target is everything should be rolled out by a click, by a pipeline, and get managed by that. We need to say about that we running this as a managed service. So we have another team, the managed service team, what is in our side, what also needs to understand what we built up in the project itself. We built it up on our standards, our KKP product. It's the same as the open source version to have these layers of APIs for making really cluster as a service available. And additional to that, we develop motorizations, like Mario mentioned already, like an S3 service or something like that. But yeah, then we came to the point, yeah, let's do this, great. And then we hit the Great Firewall. So maybe, you know, enterprise firewalls are really like something to come over. We set mostly a wonder wall to it because you don't know if there's one firewall more in between. And therefore, there was no API or any GitOps tooling or any kind of technical tooling where we can implement against. Regards that, we said, okay, then we defined objects. So we defined object groups. It's like, okay, we have data center A, we have data center B. This is one object group. This data center interface load balancer must talk to our Kubernetes workers. And that Kubernetes workers have also different groups like service workers. We have then we call it user cluster workers. In this kind of group, we make a set out of it. And this set is adopted to the customer needs. So that's something I think in every project you're starting to implement such things, you need to adapt this to the current available tools you have there. And you think maybe we wrote then a fancy operator or something like that. No, this was just a huge Excel list. What we then handed over, and the firewall team implemented it like that. With the groups, it helped us that then after we have one time the rules in place, we can just say, hey, here's a new data center. Please add this points to their dedicated groups. And that was really a success factor. What else? Infrastructure as code. I think that's really something what is in the mouth of everyone, but it's really something you need to follow strict from the beginning. Don't start with, okay, we just build it up and then we do it automate. No, please start more in smaller chunks. Start with the smallest, tiniest ETE story, and then adding the modules, adding your stuff you need, and then you have it like a growing HI system what already developers or operators of the customer can use. What also helped us is that we said we document everything side by side to the code. That means that it's easy for developers and it's also easy to review because we added this as a must-have point to the review process that we see, okay, if we finish some task, we have a documentation for it. And this is then also helpful, like we have the disaster case, the managed service team must contact our product development team. The product development team must get into the context really quick. So they just need to clone the Git repository and find the code and the documentation side by side. The next thing was standardization and scaling architecture. So that's something what our architecture of KKP already helped us a lot, that we have standardized approaches. We have one API to provision clusters between clouds. The difference for an end user to provision a cluster in cloud or on premise are 3 lines where we basically spec the cloud, the data center, what we want to use. So we have Azure and vSphere. There we have 2 locations right now in production. There will become more, like US is coming. And then we have one other thing is presets. The presets in our context is a reference to a secret. This secret is not visible for end users, only visible for operators. So, but the secrets can then get used for the cluster provisioning. But it's really cool because then I can, as a developer, create a cluster by myself without any knowledge of the cloud and the credential and how I need to provision something. So the standardized data center approach is really unique, and this process means site independency. That means every site, doesn't matter in the cloud or on-premise, should look the same. We don't want to have any cloud specific. We want to reach, for example, the S3 or the pipeline or something else in a similar way as on premise, as on edge, as on the cloud. And the setup of this data center should be repeatable in a short time. What does it mean? We have a disaster case measurement where we say we need to build it up by scratch in a couple of hours today. Depending on our depending infrastructure, but it should be really something where basically something can really get destroyed from scratch and we can build up from scratch. And how the standardized data centers looks like, Mario will show you.
Yeah, so basically when you go back in a couple of years ago, we started with, we can create containers and we can throw away containers and just use them again and again and again. And then we got to the point where we say, hey, let's run Kubernetes in Kubernetes and throw Kubernetes clusters away because we don't have to rely on them. And the logical next step is then, hey, create a template for a data center that you can potentially throw away and just build a new if you need to. So what we came up with, or what also played in our hands, is we developed, our company developed an open source software which is called Kubernetes. And Kubernetes gives you the ability to have a seat in one data center, and so multiple seats in multiple data centers, and also like one central management cluster, which is the master cluster. The good thing with this approach is basically that every user cluster where you run your workload onto only consumes 0.3 CPUs, and it's running on the worker nodes of the seed cluster. So you have a really, really small overhead in each of the data centers to have HA user clusters available for the different environments where you can run your workload onto. So you're only using the machines for what they really are, for your workload that is running inside of your user clusters in the manufacturing line. And the management layer that we have, the management and master cluster that we have on top, we said this is good to orchestrate everything and to basically to have one single point where you can say, I want to update my clusters. It's not a single point of failure. Don't misunderstand this. It's an easy way to update and maintain and manage your clusters. So if you want to roll out a new Kubernetes version to all of your user clusters, you can do it centrally. And you don't have to go into each of the separate clusters to update each of your clusters. And also you don't have to go into each of your different data centers because you can manage it centrally. The main problem that we got to was we needed a couple of more stuff to run this. So running Kubernetes clusters is fine, but there are a lot of other points services that you still need to consume. And to consume those services, to have a data center running independently, we needed some kind of service cluster. So what we created was the same structure that we had with our Kubernetes master and seed procedure. We created for our service clusters where we run different services that you need in each of the different data centers. And this goes with the same paradigm. So we have the master data in the management layer, and everything gets replicated down to. But also we have the independence that we can basically cut off the connection between the management layer and the data center. And also you can reuse these templates for any other location, because everything that is written down there and how we created it is always infrastructure as code, as Tobi mentioned. So how does our service clusters look like? Because we are living in the world of the CNCF, and we use a lot of products, we choose to go with a lot of CNCF projects here. When you look at the data center, there are some points that come obviously to your mind, like I need a DNS. But maybe some points that are not so obvious, like I need also a local registry, I need a local CI/CD pipeline, I need a local repository, and maybe I also need some local storage that I can use. And one thing that a lot of people might forget is, oh, my servers also need IP addresses. So we also need some kind of DHCP. So the lucky thing for us was we could use a lot of open source projects for this. So we use CoreDNS, we use Harbor as a registry, we use Argo as a CI/CD pipeline. For the local storage, we use MinIO, and for the repository for updates to the OS versions and OS updates, we use Nexus. But for DHCP, we run into kind of a problem because there is no containerized DHCP. So we go to and said, let's use this what is always available in the past, and use the DSC DHCP and put it into a container and see if this works. So we created a POC where we now have a running DHCP container that is giving IP addresses to our machines in our networks in each of the data centers. The good thing is now that all of those services are also running locally. As you can see, we have like an address which is called local.dns.manufacturing. This is pretty interesting because each of the applications that get deployed inside of the user clusters can use this address. So they always can use local.dns.manufacturing, so they don't need to be specific. So even your applications can be site agnostic, which is really, really great to have, like this local access from each of the local installations. And you also see there's like an S3 service missing in the master service cluster. So this is always something that you need to keep in mind. Yes, you can create standard packages, but sometimes it does not make sense, because a replica for all of the data that we have in S3 would just be useless data that just takes space. And so you need to decide for each of the services if it is really, really necessary to do this. And when we come now to our default setup case, we see that the workflow is also already an offline or outage workflow. So by default, we say we don't want to rely on the master service. So the local manufacturing line says, hey, I need a DNS entry, and then it's calling local DNS.manufacturing. It's not going to the master, which is good in several points. First, it goes to the nearest local always. Second, we save time, and it's easy to configure. And it's a default disaster case, so we don't need any connection to our master service cluster or even to our master KKP cluster. So we need to take care of a data center failure. So what is if my local data center service cluster is failing? Then we already have a failover built in. So the local manufacturing line can then either go to the master, which is running currently in Azure, or if the master is also not available, but it has somehow connection to another data center, it can then take the second data center location. And this is a real benefit, because each site that is added to the network of manufacturing sites is basically another failover that we build in. So with each data center that you build, we bring in another safety net, and this is really, really amazing for any outages or any failures. And this brings us to what went wrong in the end. And did we solve it? How did we solve it, Tobi?
Yeah. So basically, you can think about what Mario said, and the services, what consumes this are not just other Kubernetes clusters or services. These are also printers. Like we created containerized DHCP because we need IP address for printers and for tablets. So, and you can think about this quite different as maybe the normal use case. And what we learned there is there's no, okay, that's the way we do it. That's great. That's your way to go. No, we must think it in different things. We must see it more like a journey, what you do in a continuous improvement. As I said before, we should start with a small E2E case and then improving the setup and gaining the power of the platform. So in detail, what was the first thing? So the local infrastructure was the thing we started. So here we needed to align what data center do you use, how we can provision machines there. So there was the vSphere setup, how we can connect to this. So this is even a hard task because as you imagine, if every data center is independent from each other, you need also to be independent to each other. So that means if nice or mentioned service has a disaster case, but we cannot connect to the data center, then it's not helpful. So we need to also start with the simplest thing like jump hosts on this side to be aware that, okay, this disaster case are covered. This brings us to the policies. So how we can ensure that people get access to the network, to the needed security credentials, and how we can manage this. So after that, we needed to think about backup strategy. So backup cannot stored in one store. It must be replicated to multiple stores on different data center locations. Then, finally we solved it. The most thing we automated, and we created of a virtual service operation center where our people can connect in a safe way with site-to-site connections to their custom environment. This helps us then also to jump to different locations. There then on the customer side was the core infrastructure needed to get solved. So how much compute power we need, how much storage, how much network. So this needs planning on premise especially for sure, but also in the cloud you need to think about why you maybe think. So we had one case where we don't get a good utilization in Kubernetes. And the core reason was there that basically the problem was that the Azure node cannot mount more than 8 volumes. And we had there running some Kafka workload and some other database workload would create a lot of PVs. And then we basically, our autoscaler scaled up the machines to match this requirement, what was good because the service was available, but we spent a lot of costs because of that, because we used the wrong type. After we changed type, we can save like, I think it was 40% of the machines because this new machine type was capable to mount more volumes. On the on-premise side, we have the thing that we need to plan storage. So especially right now, it's this delivery times are long. We need to purchase SSDs. I think Mario helped me. It was a half year expected.
Half a year up to a year.
Yeah, expected delivery time. So that's something you need to bring up also into your plannings. Okay, so what KKP does now, we kind of abstracting this core infrastructure, local infrastructure with our platform and making a unique cloud layer out of it. This unique cloud layer means that the end developer don't feel a difference where something should run. this is great because, for example, currently they're running vSphere, but it's also an option if they are bringing a data center into it, what is just bare metal or OpenStack or something else or Nutanix, then we can just plug it in and include it in and bootstrap out a data center on top of it, and we have the same experience for the end users. Therefore, in the security part, we need to be aware that also there, like for the basic infrastructure, when you're not talking about Kubernetes in that all, we're talking about basic network segmentation, firewalling, is adapting this principle, and also authentication, so that we have one unique layer of authentication. In our case, we're using the LDAP connection and having at every cloud and on-prem the same authentication over the OIDC, what brings the user there, they can just log in with their normal user, corporate user. Next point, basically start with the beginning also with automation. If you have this paradigm already, then you're getting faster and you will gain experience, and you also will gain repeatability and testability. So if basically in the beginning of such journey, you will see that a lot of things change. And if you do it directly over automation, you will see that you can reproduce such changes. You can do it quickly, and maybe you can recreate it on the test environment. So in our case, we have multiple environments. We have like a sandbox environment where we're developing our platform stuff. We have a dev environment where mostly the services get developed for the customers, and we have a production environment. And this stages helps us to really be on the shape to get everything there in the same automation. So we just moving the automation from stage to stage. Why declarative management tools are important. There's a special thing I want to point out is maybe you have something what is not declarative, or you have some tools where nobody knows, but or written own scripts, but try to also dare to implement the declarative where you're using configs or files, what you can define what you want to achieve, and that is obvious for people where is the anchor point. And I'm personally in favor with some makefiles, because the makefiles also helps people to find quick stuff. So they have a point to do the other things, what get executed. So the makefile can be your clue code where values or config files get combined with the management tools. And here we mostly not about a Kubernetes management tool. It's mostly also other management tool, like for example, S3 controls or something like that. Services should be consumed as a service. It's maybe sounds weird, but it is like that. If you have a central platform and you have a lot of teams, you need to think it as a service to make it quick for people to consume it. You make units out of it that you don't need to deploy every service. You can have dedicated service. As Mario showed you, we have this service cluster construct by each data center where we're hosting our services and in a Kubernetes way. Why are we doing this? Maybe like the DHCP would be easier to run with as an VM, but we want to have the same capability at every infrastructure what will come to the picture. Is this cloud, Azure? Is it vSphere, or is this OpenStack? If I run this everything already in a Kubernetes cluster for my services, I don't care. And that's the thing what we want to implement. We want to do it once and then have it consumable. And just as a side note, so now we're consolidating everything and building like a predefined modularization blocks of everything, what helps us to maintain it and also to implement such things in other customer projects as well. Independence is something special for this manufacturing case, very important. So therefore, we said, okay, we have every time a smart central master. That means if a new DNS entry get entered, the change get propagated to the master, and the replicas on the data centers are just dump caches who just consume it. And this local replicas can then easily get scaled. Even if we're getting more throughput, we can scale them up, or we have a next data center, we can just spin it up in the same way. And we know in the disaster case, where is our source of truth? So that's kind of maybe not so obvious, but if you have only one management master who knows what is the detailed state, it's easy to recover. It's easy also to resync after a data center outage or something like that. This is this partial connectivity case where you need to think, okay, what happens if I have both things are online, but we are disconnected and both things move forward. So there is much simpler. You have one leader, basically, what gives you the information. For sure, each kind must be HA by itself. And that follows also the reconciling principle of Kubernetes. So this automatic reconciling is something what Kubernetes does really well. Is one of the key success factors, in my opinion. So define what you want. You want to have a deployment, you spinning up pods. Something changing, then the controller takes care to reconcile the target stage. And that's something what also the infrastructure and the architecture should follow. Same thing for the cluster management. Also here we have the same reconciling. So the seeds are independent operational, but they get only the changes from the global API. This makes it easy, and it makes it constant that during some disconnects, you still are operational. Okay, what else there is to mention is, we provision everything via API. Maybe you know already KKP, you see so fancy UI, but you can do everything also by API. What we basically integrated closely with the development workflow of the customer. They basically spin also clusters up just for testing and destroying it. We have ops tooling. What is important that everyone has the ops tooling predefined. So a new service people or someone in the product development must be sure they have the right tooling, like monitor, logging, alerting, and that's globally. Here also we have a global structure where we can get from a user cluster workload alert up to the global management, all alerts through our VSOC until we get a ring on the phone if it's necessary. So what else? If you then have support, if you take a look to the applications, they should follow a cloud native design. They should follow the same principle. Otherwise, you may be having conflicting problems. You may be thinking, what about these legacy apps? So currently, a few legacy apps are still in migration to like a cloud native design. But if they are, they can keep out of the cluster and provisioning it by Terraform or something like that. If you want to bring it into the cluster, we're not using it this customer, but could be an option to manage virtual machines with KubeVirt, where you directly can handle virtual machines like in a similar way as you're using pods, but just real virtual machines. The applications should be data center agnostic, but by using standard interfaces. What means this is, for example, the registry. Every applications consume their images from registry.manufacturing.com, but in the end, it's does a DNS lookup gives them the local nearest Docker registry cache. What means we also save bandwidth, we save latency, and we are faster, and also are safe for shutdowns. So that helps the applications that say don't need to know where to run. They can just every time consume the image from the registry.manufacturing.com, but get it every time their local miner. Doesn't matter if they run on Azure or on premise. And I really would say this is a really best practice that you can design your application independent of the cloud. You need to introduce such things because otherwise you need to manage a lot of values files and different environment specificas, and this will fail, I guarantee. Last point was for us scalability. So tuning autoscalers, as I said already with the type, find out what cost does appear. This is really, in most cases, dependent on the workload. If you have a Kafka workload, it's completely behaves differently as, for example, just a simple web server deployment. Therefore, you need to optimize also your lower infrastructure, like the machines, and also maybe the levels you want to have of the quality, like I/O intensive stuff. Like one use case was also for Minio, where people upload pictures and scan them if the production line behaves good. That means if the quality is fine, and then they do some AI magic to find out if it works. For this, I need maybe other nodes as for my Kafka service. Right, and then the most important stuff is start from scratch again, do a continuous improvement process, really challenge the things. And we worked in a 3 weeks Scrum model, and hand in hand with the managed service team, and going over these topics regularly to shape them, to make them better in shape. And from the Kubernetes perspective, we're now trying to collect this in a really industry manufacturing based solution where we have everything in place, where we can then benefit from the community and different projects, and brings us to a more like a modernization part, because we have the strong thinking every manufacturing line or industry is different, and we need to have the building blocks what we can use fastly to adapt to the customer needs and adapt it to their infrastructure. And that's basically also brings us to the main outcome. We need a platform what needs to adapt by design. So this platform needs to really adjust to the use cases, because every use case is different and every customer is different, starting from organization, starting from network design, starting from the requirements. Standardization is king, modularity is queen. These two things you should to follow. An application needs to talk with Kubernetes interfaces, not with cloud specific interfaces. Modules like can be really lower complexity. We have a service and this is one module. We have other services, another module. They should not interconnect. And with this, you gain flexibility with these predefined components, and it's easy also for other people to start with. So for example, some models what we created are now already in the product. So we throw them over the fence to our development team and say natively included it to our solution. That's what makes really success, and also us happy and the customer happy, because they have the maintained solution, and we know that this E2E tested in the whole suite.
Okay. And to bring this all to a conclusion, we basically have currently our managed setup with the numbers from April. And as you can remember, we were on 99.96% required uptime. And we managed since over 1 year to have 100% uptime running in SLA cluster with SLA setup with 39 clusters, 206 nodes, 887 CPUs, and 3.2 terabyte of memory. And also because you need to play, we have 12 clusters and 49 nodes in a sandbox and QA environment, which is not under SLA. We started the project with 2 people, so Tobi and me started it, and we got to the development ready with those 2 people, and we got to production ready and production rollout with 3 people, and currently the team consists of 4 people plus 24/7 managed service team.
Here we must focus that people are mostly working on the additional service around Kubernetes, like we providing S3, then registry also for the users, DNS services. All these services are or have been not in the core focus of us, and this is getting more or less developed now, and the focus is more on these additional services as on the Kubernetes, plain Kubernetes stuff.
Are there any questions? So I give you some time to write down questions if you have some, because I need to do some advertisement. There are Kubernetes Community Days happening in Berlin from June the 29th to June the 30th. It will be a great event with a lot of speakers on site and in the heart of Berlin, which will be really, really cool. And you can still join. And the CFP is also open until tomorrow. So if you're fast, hand in your call for paper. All right. I do not see any questions.
Comments are also welcome.
You can always reach out to us. Thanks for joining, everyone. You can reach out to us via Twitter or via our website, or personally personally on Twitter, of course. If any questions come up in the future, just ping us. And yes, the recording will be available in the coming days, and also the KubeCon recording will be available by the 6th of June. All right, then I would say just in time, 2 minutes left. Have a great afternoon. See you soon on another webinar, or at least in Berlin, or on Container Days in September in Hamburg. Thank you very much.
Thanks everyone for joining.
Bye-bye.
Thank you.